They noticed on like the update billions, they made it update time lower and costly. Dude, I messed it up.
All right. The first group, excluding hydrogen. What's the name of it? No.
Halogens. Halogens are the other one that noble gas system.
Alkali metals.
Oh,
You said line. You had line.
What do they have? How many valence electrons?
Cinco to mine.
They have 1 valence. What about their charge when they become ions, known as the ionic charge?
Positive charge.
So +1. The next group includes beryllium, magnesium, and so on, is called
The alkaline earth.
alkaline earth metals. Y'all quit talking. They have how many valence? And their charge would be +2. Helium is hydrogen is by itself. It has how many valence? And what was this ionic charge? +1 or -1?
Okay, beat it.
Because the first energy level is full when it gets 2. And remember, you're either trying to fill it up or remove it. So you can either remove the electron, making it +1, or you can add another electron, making it have 2, and give it -1. So the first hydrogen and helium are exceptions. Then we have in the middle the transition metals. And right here we have these. They are called, we'll just call it that, rare earth metals. We definitely won't be focusing on them.
Is that what? We're earth metals. I thought we are.
We are in chemistry.
Oh, no, I mean like those.
Oh, the other class? We occasionally look at them, but not often. Then we have the boron group. It has how many valence? 3. And what's its charge? +3. Then we have the carbon. It has how many?
+4 or -4?
It has 4 valence electrons, but you are right. The charge will be +4 or -4. Then what elements comes next? So nitrogen group. It has how many? 5 valence. And what was its charge?
30.
-3. So once we get to this halfway point, we need to start decreasing. And then we have oxygen. It is 6 valence, -2. So everything in it is -2. There are exceptions, but we will ignore them. Halogens. Halogens include fluorine. They have 7 valence and -1. And then lastly, the noble gases. 8 valence, and they have 0 charge because they don't react. Helium is an exception. I'll write down here. Helium has 2 valence electrons, but still 0 charge. It has 2 because, again, the first energy level. So we have 2 protons, 2 neutrons, and then 1 energy level with 2 electrons. So, what is the charge? And y'all needing the periodic table almost every day. So, what would the charge of aluminum be? Aluminum forms plus 3 ions. And what would oxygen be? And when they react together, what compound do they make?
Aluminum oxide.
And what's the chemical formula? Al2O3. So using the crisscross method, 3 comes over here, 2 comes over here. So if I have X with sulfur, when did it turn off? So if I have X with sulfur, what charge is the X? If I have a mysterious element X, what must its charge be?
I'm going to assume that's 2.
So what charge does sulfur have? And X has to cancel it out. So it must have a plus 2. The plus 2 and the negative 2 would cancel each other out. What about now? What is the X?
Negative. No idea.
Yeah, F2.
So fluorine is -1, and we have 2 of them. So we have to counteract these 2 -1 charges. So X must have a plus 2. Plus 2 minus 1 is 0. What must it be now?
Well, if it takes 2 to get off,
So yeah, so oxygen is -2. And we have 2 X's. And the only thing that add up to -2 to counteract would be 2 plus 1 charges. So plus 1 and plus 1 will get rid of the -2. So that means the X must have a plus 1 charge. Make sense? So we're going to learn some nomenclature. Let me make sure I have the correct spelling. Do y'all know what the word nomenclature means?
something about knowing in the country.
Have y'all ever heard the term nomenclature? It's a naming scheme. It's a scheme. How do you spell scheme?
S-C-H-E-M.
S-C-H-E-M-E. It's a scheme for naming things. Usually in science. So let's say that we have 2 elements. So we have precisely two elements. So we have an element A. I don't really want to use B. So I have an element here and an element here. And they have some numbers out here. But this is only a single element, and that's a single element. We always write the cation first and the anion second. So negative ion is written second. Cation is first. How we're going to name it? The name of this will be the name of the cation, unchanged. And if the anion is an element, meaning a single element, then add or change suffix to IDE. So it'd be the name of anion with IDE ending. So let's try some. Al3O2. The cation is aluminum, and the anion is oxygen. So we write down the name of the aluminum, the cation, unchanged. But now we're going to change the name of the anion such that it will end in IDE. Oxygen becomes oxide. The YGEN becomes an IDE. The Y acts as a vowel in this case. And it's the pivot point right there. So NAF, what would its name be? Michael, keep your head up.
Sodium fluoride.
What would it be? Sodium. So the first part doesn't change, and this becomes fluoride. Alright, what is this? So this will be calcium iodide. You do not put iodine, so that's wrong. What about this? I2.
Iodine.
This is iodine. Again, this naming scheme only works if it's an ionic bond. This is not ionic. This is actually elemental iodine. What about this? Oxygen. What about this? This is oxide. So this is the name of the anion. So this portion right here gets this name, while this portion gets this name. We usually would call Ca+2 calcium ion. While we would do I, -1, would just be iodide. But you could do iodine ion. Would be acceptable too. Alright.
Magnesium.
What is the formula for magnesium fluoride?
MF2.
Michael, eyes open. What would it be? MgF2.
I was right.
So you didn't put a G. So it's Mg plus 2 right there. This is F-1. We need 2 of these to counteract that plus 2 charge. So these are known as binary element naming scheme. Michael, stay awake.
Is that Minecraft music?
What would this be called?
Sodium calcium oxide.
No calcium in that.
Oh, hang on. Carbon. Sodium carbon oxide.
No.
God.
Michael.
Sodium carboxide.
Exactly.
So we always name ionic compounds with 2 words.
Sorry about that.
Thanks. Ionic compounds have 2 parts. They have a cation and an anion. What would be the cation in this case? So Na plus 1. And whatever's left, CO3, must be the anion. And what would its charge be?
Carbon be plus.
This is treated as one thing. You treat this as one single ion.
-7.
So there are 2 plus 1 charges. So we have Na plus 1, Na plus 1, and then we have a single CO3.
The carbon is plus 1.
Again, it's CO3 is one thing. There's no carbon by itself. So this whole thing is -2. These are known as oxyanions. This is known, so CO3 -2 is called carbonate. The 8, so oxyanions end in -ate or -ite, or they might have a per-ate, or they could have a hypo-ite. They're going to have these weird endings. Oxyions, so if you see an 8 or ite, so 8 or ite tells you the ion has oxygen attached to it. Michael, remove your hand and stay awake. let me find. I have a nice mnemonic or not mnemonic, but picture you can do. To remember the charges. So most 8s end in 3 oxygen. So most 8s have 3 oxygens. Sulfur, phosphorus, sulfur, arsenic, and cesium, or selenium, and they're right next to each other. These 8 oxyanions have 4 oxygens. Ite means remove 1 oxygen. Doesn't affect charge. And if you do a hypo in front of it, remove 1 more. Or 2 from the 8 version. And adding per in front of the 8 means add 1 oxygen. So, for example, we have CO3, -2. This is carbonate. If I add an oxygen, so CO4, charge doesn't change. This would be per carbonate. Michael, stay awake. If I remove an oxygen, this becomes carbonite. And if I remove another oxygen, we don't write the 1s. This becomes hypocarbonate. And if I remove 1 more carbon, 1 more oxygen, what does it become? Carbide. If it's an ion. So, note that only the oxyions have oxygen. This is just an elemental ion of carbon. And these are the ions versions of it. Yes. Michael, stop drifting off to sleep. Keep your eyes open. So, looking at the periodic table, carbon. It's I E. Michael, stand up. No, stand up. And pay attention. Don't just be looking out. Ooh, how do I get off?
R-N.
I forgot fluorine. Gosh dang it.
And but underneath X, E, and R. Oh, that was cool. Change the M to a K.
Alright. Do y'all remember where the metalloid or zigzag line is and how to draw it? So we draw our line. Don't lean up against the wall. No, you were doing good. Alright. So we're going to draw a T right here. Then we're going to draw a square. And then we're going to group these three. Technically they make a 4 out of this. I'll do that. They include this one, but you can ignore this one into it. And then they do a 3 right here. But you can ignore these 3 over here. So this is 3A. So we're going to start with 3 negative charge. Negative 2 charge, I'll do it. Negative 3. Then negative 1. So this T is where we're going to begin with negative 3, negative 2, negative 1. These, let me scoot. Again, we're always going to start with negative 3. These all have, and I'll quit talking, these would have negative 2. And then these would have negative 1. And these don't. So, NO3. So these and these have 3. These have 4 oxygen for the 8 version. What would this be called? And it would have a negative 1 charge. So if it's in this group or this group over here, it has the 3 version of it has 8. So this would be called nitrate. If I remove an oxygen, it becomes nitrite. And if I remove one more, it becomes hyponitrite. And if I add one more, it becomes pernitrate. So let's look at, for example, potassium. Or let's do magnesium. Magnesium. Magnesium nitrate. So we know the magnesium has a +2 charge. Nitrate, well, the 8 tells you it's going to end with an O3. The nitra part tells you it's an N. And this tells you it's a -1 charge. We need 2 of these nitrates to counteract the plus charge here, yes. Be quick. And then you can go after Michael. So the formula would be NO3 with parentheses around it, a 2. Because we have 2 NO3s. So the formula for magnesium nitrate is Mg, NO3, and put parentheses around the NO3 with a 2. What about sodium sulfate? What would its formula be? So what is the ion version of sodium?
Sulfide.
Na+1. What would sulfate's formula be? So SO. So 8 usually means 3 oxygens, unless it's one of these. Sulfur, in which case we use a 4. And the charge is -2. So you'll notice these match up. These have the same charge as the nitrogen group. These have the same charge as the oxygen group. These have the same charge as halogen group. It's these two that are weird. So we need 2 sodium to counteract the sulfate. So sodium sulfate is Na2SO4. That makes sense? Alright, let's do calcium chlorite.
It's calcium with chlorine.
So what is the ion of calcium? Ca what? Why y'all keep saying Cl when I'm asking about calcium?
Oh, calcium. Jesus.
Calcium ion is what?
Cl. Not chlorine.
Cody, what is calcium's charge? That's why I retold everything today.
Calcium's charge.
Is what? Someone answer it. What does calcium become when it becomes an ion? +2. What would the formula for chlorite be?
CaO.
So CHLR tells you it's chlorine with oxygen. So chlorine with some oxygen. The ite tells you it has it. Let's look at chlorate. Chlorate. Remember, all the 8 end in O3 unless it's phosphorus, sulfur, arsenic, or selenium. It's none of them, so the 8 is going to have an O3. So it'd be ClO3. The ite tells us to remove an oxygen. So it's ClO2. And all of the halogen oxyanions have a -1 charge. So we need 2 of these to counteract the +2 here. So it'd be Ca, ClO2, that is calcium chlorite. With a 2 here. So this is calcium chlorite. And what about calcium chloride? What's its formula?
CO2.
So Ca plus 2. Chloride, the I tells you it's elemental, so it's just Cl. And it's -1. There is no oxygen. And we need 2 of them to counteract the plus 2 charge. So it's Ca, Cl2. One of the things we're going to be doing in my real chemistry class soon is the gummy bear reaction.
Oh, I saw that.
It uses potassium chlorate. What is the formula for potassium chlorate?
Potassium, 1Cl.
So potassium is +1. What is the formula for chlorate? So 8 is almost always O3 unless it's phosphorus or sulfur. So the 8 version always refers to O3 unless it's sulfur or phosphorus. And chlorine tells us it's going to have a -1 charge. So this is a 1-to-1 ratio. The +1 is counteracted by the -1. And it gets this formula right here. Once this is heated up past melting point, a little higher than melting point, it undergoes decomposition. And this makes Cl plus oxygen. Which I need 3 of these, 2 of these, and 2 of those. And oxygen, it will react with sucrose sugar in the experiment. Magnesium phosphate. What would its formula be? So magnesium, what's the ion of magnesium? And phosphate is one of our exceptions. The 8 version for phosphorus ends in O4.
Is phosphorus and sulfur the two exceptions?
Yes, and the ones below it. It makes arsenic and selenium and beryllium. But I will never give y'all arsenic and selenium and beryllium. Phosphorus and so sulfate and phosphate are 2 very common ions. What would the charge of phosphate be? -3. So when we have a 2 and a 3, we can crisscross. So 3 is going to come over here to the magnesium. And the phosphate needs to be grouped together. Cody, quit talking. And grouped like that. So this is magnesium phosphate. Again, this whole thing is treated as one single thing. It's one ion. little trick in case you don't know how to get the charge. If you see this somewhere on the test, you can figure out what the charge of phosphate is. We know that these charges have to cancel each other out. We know we have 3 magnesiums, and they have +2. So 3 times +2 gives us +6. We know we have 2 phosphates with some negative charge up here. 2 times what would give you -6? -3. So we know that this +6 has to be countered by a -6, and we get 2 over here. What would this chemical be? What would be the name of this? So we know it has 2 parts. Every ionic compound has 2 parts. We have an SO3. What is the charge for SO3? -2. And we know sulfur is an exception. Sulfur, the 8 version, so sulfate, is SO4 -2. We've removed an oxygen, so this must be sulfite. And we know that this right here has to be grouped together. We only have exactly 2 parts. So we have an NH4. What would be the charge of this NH4? Mm-hmm. So we have an X with a 2 and a Y. We know the Y has a -2 and there's 2 X's. So each X must be a +1. Does anyone know what this is?
No, sir. Nitrogen compound. Nitrogen hydrogen.
Ammonium.
Ammonium.
Not to be confused with NH3. What is NH3?
Ammonia.
Ammonia. Ammonium is an ion of ammonia. As an additional H, hydrogen. Which brings it to +1. We're adding a proton to it. This is about one of the very few positive ions. And by the way, all of these are called polyatomic ions. They're ions with multiple atoms. And they're treated as one whole thing. Anyone know what saltpeter is? Saltpeter. None of y'all ever made gunpowder? Or looked up how it's made?
Sulfur. Yeah, it's sulfur. Thanks, that'd be crazy gunpowder.
So you're right, it's sulfur.
And then it's dude, don't you like or something? Big
Charcoal.
Big bang people download.
Spell it.
Man, it's fucking how to make a ball.
And saltpeter. Saltpeter is the alternative name for potassium
Iodine.
nitrate.
Oh, good.
So what's its formula?
SC something.
Ignore this part. Just looking at saltpeter. So we have K plus 1 nitrate. So that's an O3 with a nitrogen. This has a -1 charge. So it's KNO3. Do y'all know what baking soda is?
Yes.
What is the chemical name for baking soda?
Baking. GA something.
Baking soda is sodium. Guys, quit talking. Bicarbonate. What do you think the bi in this word means?
Two genders.
Hydrogen. So it's NaHCO3. The bi means add hydrogen to the carbonate.
You said